Have you ever really stopped to think about what's happening under the hood when you run your Java code? I mean, deep down, inside your computer's memory. Getting this right is one of those things that can seriously level up your programming skills. So today, we're going to pull back the curtain and make it all make sense.
Okay, let's just jump right in with the question. You've probably typed new thousands of times, right? New car, new string, whatever. But where does that car object actually go? What corner of the computer's memory does it live in? That's the exact mystery we're about to solve.
So here's our game plan. First, we'll look at the two main worlds of Java memory. Then, we'll zoom in on each one, the stack and then the heap. After that, we'll watch them work together with some actual code. And finally, we'll talk about why this isn't just theory. It's stuff that will make you a better developer.
All right, first things first, you have to understand that when your Java program gets memory, it's not just one big messy pile. Oh no, the Java virtual machine is way smarter than that. It neatly divides memory into two very distinct, very organized areas.
And those two worlds are the stack and the heap. The easiest way to think about it is this. The stack is like a super organized, super fast, but small desk where you keep your current to-do notes. The heap, on the other hand, is like a giant, flexible warehouse where you store all the actual big stuff you're working with. They have completely different jobs, but they are the perfect team.
So, let's zoom in on the stack first. Its name is actually the perfect clue for how it operates. Seriously, it works exactly like a stack of plates. When you call a method, Java puts a new plate on top of the stack. That plate holds all the method's local variables. And when the method is done, whoop, that plate is popped right off the top. The last thing you put on is always the first thing you take off. It's simple, it's rigid, and because of that, it is incredibly fast.
And here's a super important detail. The stack stores simple, primitive types, like an ant or a boolean, directly. The actual value lives right there. But for complex things like objects, it doesn't store the object itself. Nope, it just stores a reference, basically a small pointer, like a sticky note with an address on it that says, the real object is over there in the heap. This is a huge reason why the stack is so fast and small.
Okay, so if the stack only holds the address, where is there? Well, let's head over to that other place, the second major memory area, the heap. If the stack is that neat little pile of plates, the heap is a massive, wide-open warehouse.
This is it. The heap is where all of your objects, every single one you create with the new keyword, actually live. It's called dynamic because objects can be created and cleared out in any order, whenever you need them. There's no strict last-in, first-out rule here. It's much more of a free-for-all.
So the heap is where the actual object data lives. Because it's this big, shared space, it's a little bit slower to get to than the stack. The good news? We don't have to clean it up ourselves. Java has this amazing process called the garbage collector that runs around in the background, finding and deleting objects that we're not using anymore. It's a lifesaver, for sure, but keep in mind that this cleanup process isn't free. It takes time, which is why creating millions of unnecessary objects can really slow down your application.
Okay, theory time is over. We've met our two main players, the stack and the heap. Now for the fun part. Let's watch them do their dance. We're going to walk through two simple lines of code and see exactly what happens in memory step by step.
Here we go. Line 1. Car, my car. That's it. Notice what's missing. There's no new keyword. All we're doing here is telling Java, hey, I need a variable, a little box, that can hold a reference to a car object later on.
And here's what happens. Instantly, a tiny piece of memory is set aside on the super fast stack. It's a little slot labeled my car, but right now it's empty. It points to absolutely nothing, or null. The giant heap warehouse, it's completely unaware. Nothing has happened there yet. And now, the magic word new. My car equals new car. This is the command that actually creates our object and brings it to life. This one little line is going to involve both the stack and the heap.
So check out this two-step process. First, the JVM goes over to the big heap warehouse, finds an empty spot, and builds a brand new car object from the ground up. Then, it figures out the memory address of that new object, comes back over to the stack, and puts that address into the little my car box we created earlier. And just like that, our stack reference is now pointing to our actual object over in the heap.
So let's just recap that journey real quick. Step 1, you declare a reference, which creates a small empty placeholder on the stack. Step 2, you use the new keyword, which builds the real object in the massive heap. And step 3, the address of the object in the heap is given to the reference on the stack, linking them together. That's it. That's the heart of how objects work in Java.
So, okay, we've gone through all the mechanics of stack and heap, but let's get real for a second. Why should you actually care? How does knowing this stuff make you a better programmer?
Well, it really comes down to this. Anybody can write code that sorta works, but understanding what's happening in memory is what lets you write code that is efficient, stable, and easy to debug. It's a total game changer.
And here's what you get. These are your new superpowers. Ever seen a Stack Overflow error? Well, now you know exactly what that is. You've literally overflowed the stack, probably with a method that calls itself too many times. And the most famous error of all, the null pointer exception? Yep, that's just you trying to use a reference on the stack that's pointing to nothing. It's not pointing to an object in the heap. Knowing this stuff lets you fix bugs faster, write better code, and absolutely crush those technical interviews.
So, I'll leave you with this final thought. Now that you know the stack holds the pointer and the heap holds the actual object, what's that one common Java error that suddenly makes perfect, crystal clear sense? Think about it. Once that clicks, I promise, you are never going to look at your code the same way again.